Let's figure out some more of these, and we're going to do them on the board right here. So I have 3 written on the board, there on your paper, and I want to find the limit as x approaches 0 of e to the 2x minus 1 over x. Okay, here's my first thought. Before we put anything on paper or board, let's say, ooh, can I plug a 0 in? No. And actually, if I plugged a 0 in, well, I'm scratching my head like I'm thinking about it. If I plugged a 0 in, I'd have 0 in the denominator and I'd have 0 in the numerator. If this was a free response question, then I would need to demonstrate that. So I'm going to grab a different color marker and I'm going to say that the limit as x approaches 0 of e to the 2x and then minus 1 is going to give me e to the 2 times 0 minus 1, which is 0. We have just determined the numerator would be 0. And now we're going to determine that the denominator itself is 0. And this looks like a lot of common sense. But we have a situation where we would be dealing with L'Hopital's rule. Again, we cannot say this equals 0 over 0. Nothing equals 0 over 0. Don't play that game. Don't put that. You lose points for that. It's not cool. It's not mathematically correct. We demonstrated its 0 over 0-ness in this way. And because we just demonstrated its 0 over 0-ness, we will proceed with L'Hopital's rule. So let me grab a marker that works. I have a whole tray of them down here and they don't all work. This was a good one though. So we're going to find the limit as x approaches 0 of the derivative of the numerator, the derivative of the denominator. Denominator is pretty easy, right? Okay. The derivative of the numerator is, well, the negative 1 goes away. E to the 2x becomes e to the 2x. Chain rule means I multiply by 2. There we go. And now it is totally okay, perfectly okay for me to plug in a 0 for x. So I will have 2e to the 2 times 0. So 2 times e to the 0. E to the 0 is 1. I have 2. Found it. Okay, let's do a couple more. This next one actually is going to be super easy. And I'm going to jump straight to the answer. I hate to blurt things out, and it sure would be a shame if I just went ahead and wrote stuff down and didn't even explain it, because I would hate it if that happened. It would be just so tragic if you found out what the... Anyway, let's just cut to the chase. Here goes. Based on a lesson you have learned before, limits at infinity, you can see that the numerator is a logarithm. The graph of a logarithm increases very slowly. Okay, this is like a magnitude of a logarithm. It's just very slow. The magnitude of a polynomial is a lot higher, and because we're approaching infinity, the denominator overpowers the numerator. So because the denominator overpowers the numerator, that's why the answer is 0. If we wanted to figure this out using L'Hopital's rule, let's take the derivative of the numerator and the denominator. So the limit as x approaches infinity of, and I didn't go through all this on this one. We already know it, so I'm not going to. I don't see the need, because actually this one you could just say equals 0, because we just know it. But here we go. The derivative of natural log of x is 1 over x. The derivative of x cubed is 3x squared. So yeah, plugging in infinity is still not going to work. In the end, you're still going to have to use your infinity knowledge. You have infinite knowledge. Please use it wisely. Okay, 1 over x divided by 3x squared is 1 over 3x cubed. Okay, trust me, it is. It works that way. You can kind of write this out and it works. As you do this, you realize clearly the denominator has a higher magnitude than the numerator, which is just a 1. So this is equal to 0. That's it. Okay, last one's tricky, and we are going to do a little bit of stuff with what I did in red on this one. Again, for this one, it was like, man, I could have jumped straight here because I know it, right? I'm going to erase this so I can bring my work up a little bit on this one. So L'Hopital's rule applies on this one, and I am going to demonstrate it by using, well, doing it in my head first. So 1 goes here, I'd have 3 e to the 0, so that's 3. 3 minus 3 is going to give me 0. So let's just demonstrate that, because I sure would hate to just move ahead and the people that are grading my paper would say, why is he doing this? Why is he using L'Hopital's rule? He didn't even demonstrate that we need it. So here we go. But again, don't say equals 0 over 0. Don't even try that. Don't play that game. X minus 1 minus 3 is equal to, well, if I plug that in, I would get 0. I'm demonstrating that I know the numerator is 0. Let's demonstrate that we know the denominator is 0. And And let's see, 1 goes here. Cosine of 0 is 1. 3 times 1 is 3. So 3 minus 3 times 1 squared. So 3 minus 3, still 0. We will definitely use L'Hopital's rule. We're good to go for L'Hopital. Let's take the derivative of the numerator and the denominator. This one's going to get a little bit tricky. Okay? So here we go. Still haven't taken the limit yet. So it's the limit as x approaches 1. Numerator, okay. The negative 3 just goes away. 3e to the x minus 1, the derivative of e to the whatever is e to the whatever. Multiply by the derivative of that exponent, which is 1. And we already had a 3 there. Okay, let's find the derivative of 3 cosine of whatever. So the derivative of 3 cosine will be negative 3 sine of that, multiplied by the derivative of that, which is 1. So nothing changes yet. Derivative of 3x squared. 6x, subtracting. Okay, if I plugged in a 0, if I plugged in a 1 now, what would I get? So let's do it in our head, and then we'll go from there. If I plug in a 1 now, I would have 3 times e to the 0. That's 3. Okay, we're safe already. We know it's not a L'Hopital situation. We might be dividing by 0 in the denominator, but, you know, still, numerator is the 3. We're not going to have 0 over 0, infinity over infinity. Never going to have that stuff in this situation now. 1 goes here. Sine of 0 is 0. We have negative 3 times 0. So 0 minus 6 times 1. We're good. We're not dividing by 0. So let's just plug it in now. I'm going to stand in the way because I don't care if you learn or not. I'm kidding. I do care. So 3e to the 1 minus 1. It's going to give me 0. No, it's not. It's going to give me 3. Wow. Good job there, sir. Okay, we're going to plug a 1 in here. We're going to have negative 3 times sine of 0, which is just 0, minus 6 times 1. So negative 6. Negative 1/2 is what I'm going to get for that one. That's it.